In this problem, in this video, we will write a function to reverse a linked list in both normal way using iterators and using a recursive way. First, we will use iterative way. So I think I already solved this problem in one of the palindrome question, which is like a very first question in this series of assignment. So basically what I'm going to do is like I will just take three variables. For example, I'm going to use the same variables, current, previous and next node. Okay, I'm already assuming like there is a linked list available developed, like class node, and then this node will take data. Okay, I'll just write a simple self self dot data equal to data self dot next equal to none, class linked list. We just assign a head pointer here, define init self data. So we just take head as initially we make self dot head equal to none. So this is like a basic linked list that I quickly wrote it, and then we write inside the linked list for reversing linked list. Okay, so to come up with our solution, I'll just take three variables. One is current, previous, and one is next. So what I'm going to do is like okay, so the current will point to head, and these both will pointing to null. So what I'm going to do while traversing, I'll just traverse the list, and then while traversing I'll change these variables. Like how changing is like, before changing the next of the current, I would like to store the next node, and then like next equal to current dot next or something like that. And then okay, I think I'll just write it. So for reversing, we don't really have to pass any inputs. I'll just current, previous, next node, previous equal to none, and then current, I'll just mark it to self dot head. So once I have assigned these two, I'll just write a loop for traversing through the linked list. So while current is not equal to so this is where we do our next, will make next equal to current dot next. So this is where we make the variable. So before changing current, we assign the next variable to current dot next. Now we make this we do this current dot next equal to prev. So this will point to a previous variable. Now we change the current to next. So after doing this, we technically have each element is ready. So now we make self dot head equal to prev. So this is how we can iterate the linked list by using a recursive way. But sorry, we can reverse this by using recursive way as well. So this is like iterative way. So this one should be a recursive approach. So in recursive approach, what we're gonna, so we'll be using the same thing here. We'll do define, I'll just make a rev. So for recursive approach, we should have head as input. So the reason again self is like I wanted this to be inside this linked list class. If you don't want, if you want it to be standalone, then you can just ignore this self part. And then now we have to break the loop if head is empty or reach. We can just break it because I wanted it to be like a base class. So we make, now we say if head equal to none, or head dot next equal to none. So if this is, if any of this case meet, then we just return head, and then we just reverse the rest of the list. So now we'll make a real variable, we'll take one variable, and then we just call it self dot rev, and then we pass the head value, right? So now we already have a head, we just make head dot next. So every time it will go to the same function and then call itself. Now we have to put first element at the end. So we'll be making the first element to the head. So head dot next equal to head, and then we make head equal to head dot next equal to none, and then we just return real. So this is to fix the header point, and this will take care about reversing the linked list, and this will just call the function till it reaches to any of these conditions. So both of these cases, it shouldn't be taking more than any time. We just use a linear way, so it's gonna be big of n time complexity and big of 1 space complexity. So just for testing purpose, we just say 1 2 3 4. So this is like our example linked list, and output should be 4 3 2 1, this pointing to none. So in this function we just make so initially this one points to a head pointer. Now we make the next equal to current dot next. So next pointer will be heading to second here, number second element. So once we have the next element, we make this current dot next equal to we make this as a previous element, and then we make current equal to next. So this is how we're doing in the normal iterative approach. In recursive approach, it is same as iterative approach, but it is something different, because here we are calling the same function every time, and then we are making these three operations after calling this function.